All right, thanks for having me. So my name is Byron. I work on the developer platform team at Airbnb. My team builds all sorts of internal tools and platforms for engineers and other technical roles. As part of this, we're always looking for the highest impact ways to make a difference for our engineers. And currently, spoiler, generative AI is right at the top of that list in terms of the impact that we're seeing. So to kick that off, let me show you a little bit of data backing that up, maybe helping to motivate some of your own efforts in this area. So we care a lot about the opinions and feedback from our developers, and this helps us sort of point us in the right direction when deciding how to invest. So we like to give out these developer experience surveys. What you see here is one of the questions we ask our devs on our biannual survey. This is sort of a good way of validating that our investments are at least feeling like they're paying off for our users and helps us decide on future investments. Well, in our latest surveys, the most common response to this particular question has always been about the AI tooling that we've been building and deploying internally. And so on the last survey, we actually dug further into this by asking straight out, how much has AI tooling increased your overall dev productivity? And we were shocked here. Half of the respondents believe that AI tooling improved their productivity by at least 20%. In the P90, this was even more extreme. These engineers believed AI tools boosted their productivity by 45% or more. Of course, people aren't always reliable at estimating their own productivity, and surveys are just one part of holistically measuring the dev experience, but we rarely see a single initiative get such positive reviews. Overall, it's looking like the return on investment we're getting from investing in AI has so far been extremely high. So what are these tools that our devs are so enthusiastic about? Before I get into this, let me just say this is a huge space, obviously. If you're on AI-oriented social media, every day you'll hear something about some new developer tool, often with a really impressive demo. Sometimes those things work out really well in practice, and sometimes they're more just great demos that give some promise for the future. And similarly, we've been working on a number of different ideas. But what I want to focus on today are just the highest impact efforts so far, the key things that have gotten us the vast majority of the real impact for our engineers. And that largely revolves around just nailing the basics of AI. So those fall into three main categories at Airbnb. First, there's chat, which everyone knows and loves. We provide different types of internal chat interfaces, both internal web and IDE interfaces that are developed by Airbnb. And that's been a huge win for engineers. And the web interface has actually been popular amongst non-technical employees as well. Next is IDE autocomplete via GitHub Copilot. This one needs no introduction, I'm sure. Copilot is a plugin that runs in your favorite IDE, and it's available in just about every IDE these days, even in NeoVim. It's been a great success at Airbnb, and I'll dig into some data backing that up later. And then finally, I'm going to talk about some of the interesting platform work we've built internally. We built some platforms that any dev can use to build their own LLM solutions, including tools that can be integrated at various steps of the development process. And this has helped us go past the basics and enable all engineers to quickly prototype useful things, either just for their own team's usage or for everyone at the company. So first, let's start with chat interfaces. So chat with LLMs have been out for a long time now. So what are the usage cases that we're seeing engineers use? In short, LLM chat accelerates just about everything. This is probably still the highest impact AI tool available today. So let's walk through how chat is being used. First, for coding, lots of engineers do something like pair programming along AI or alongside AI, or when working in unfamiliar domains like a new language. This is an area that's advancing rapidly with new LLM model releases. This is useful in loads of contexts, but especially for self-contained work like scripting, for example. Next, writing tests. AI is often quite good at generating tests. Paste in your function, maybe specify some mocking frameworks, and it'll give you a test, or at least something to start from and sort of fill out there. Recently, we've seen some people actually handwriting the test first, showing it to the LLM, and getting it to generate a draft of the actual code, sort of like an AI-assisted test-driven development. Next, debugging. LLMs are often amazing at debugging unfamiliar things. The next time you get some cryptic error, just copy-paste it into an LLM. Don't even bother adding context. Don't even tell it what to do, and see what you get. They're great at teasing apart errors coming from just about any public tool or framework especially. And then, provided the related code or configs, they'll point you in the right direction for a fix. This is useful enough that we've even thought about building sort of an automated build error debugging tool. And I'll talk about the platform that would enable that sort of thing later. Next, refactoring. Describe the change that you want, dump the code in, and after a little back and forth, you're probably 80% of the way done. It's not great at tackling complex changes across multiple files at all yet, but it's good for more tactical refactors. And we're seeing early signs that the new OpenAI o1 models are especially amazing at this. Next, writing docs. It's easier to dump unstructured thoughts and data into chat and have the AI clean up the style, the grammar, and everything. Next, internal engineering support. This is one of my personal favorites. I'm sure many in this room can relate here. When we first hooked up LLMs with RAG, some colleagues started copy-pasting Slack support threads verbatim to AI and copy-pasting the response back. And they found it solved a surprising portion of the problems. So, spoiler for later in this talk, but maybe your first line of defense in dev support threads is actually AI. So how do we enable chat? First off, this is our web interface for chat at Airbnb. This is the first interface we provided and is still the most popular. People love using LLMs by the web. It's a busy slide, I know, but let me walk you through it. Right at the top, you can pick between two distinct chat offerings. First is a vendor RAG integrated chat, and the second is our layer directly on top of various LLM APIs, mostly in Azure OpenAI. The vendor's primary audience is non-engineers and works very well as in sort of an internal information search. It hooks up to a really large number of information sources, and access controls to those data sources work seamlessly. So you can even search over private files, private Google Docs, these sorts of things. This uses a more elaborate RAG, and we'll talk about what that means later. We find this does best for less technical questions, especially things that are super specific to Airbnb. And new employees to the company tend to rely on this a lot before they know where to look for things. On the other side, One Chat is the name of our own internally built offering. In this, we're able to provide more configurability. You can tweak the system settings. On the left, there's a switch to turn on our own RAG, which we're calling Airbnb Aware. And lastly, you can pick your preferred model, so we can use models with higher reasoning ability. This allows access to a variety of OpenAI and other models. Diving deeper, this is the same UI, web UI. On the right, you see the expected, my colleague talking to a bot. It works about like you'd expect, almost like a public web chat GPT, and we give access to your conversation history as well. Diving deeper again into the same UI, on the right, advanced settings I mentioned earlier. You can adjust token limit, the temperature, the system message. Most people don't understand these and just stick to the default. Sometimes folks will tell them a little bit about their job role and how they like to be talked to in the system message. For example, my system message just says I'm an infrastructure engineer at Airbnb, and I like to think that tends to skip some of the fluff in the technical responses. Anyways, that completes the tour of the web UI. Nowadays, there are several open source options to at least start from that will give you similar functionality if you don't have something like this already. But web chat is just one interface we expose for engineers, and let's quickly talk about others. Here's a quick comparison between the chat interfaces that we offer. First, there's One Chat. It's not very well integrated into the developer flow, but it's convenient for whatever you're working on, even if that doesn't involve an IDE, like some sort of production issue. But a key goal of ours is to integrate deeply into the developer workflow, so we also offer IDE plugins, the first of which is Copilot Chat. It's honestly gotten some mixed reviews for response quality so far, but it's able to pull in context from the IDE, and we enable it alongside the Copilot autocomplete. A minority of people like to use this one. But our main investment right now is actually in our own internal IDE plugins. We have plugins for VS Code, JetBrains IDEs like IntelliJ, and for Xcode. These are able to talk to the latest best models with our internal RAG, which I'll talk about shortly. This gives us the great IDE ergonomics while having access to Airbnb-specific context. And this also gives us a place to prototype more advanced features, like tools that make some code modifications automatically or review your code for you. We're not going to dive into the UX in those IDE plugins today, but we'll talk more about the infrastructure that powers it shortly. First, let's talk about RAG. For those that aren't familiar, this is a fancy phrase for adding more background information to the prompt so that the model can answer questions that aren't in its training. This is how we implemented that Airbnb Aware switch from the UI that you saw earlier. Let's dig into how RAG actually works. Now, first off, let me say this is a surprisingly deep space with lots of research and work going on by many companies that's really great. So I'm not going to dive too much into the implementation details, but I want to at least give you the TLDR. So the general goal of RAG is to give relevant context to the LM on what the user wants to know about. And you combine that info with the user's prompt in some way so the LM can generate the best response. For example, maybe you search your internal documentation for relevant info and quietly pass that along with the prompts. Or in an IDE plugin, you provide some full source files that the user is working on to the LM. You can even give the LLM different tools and code that it can use itself to search for relevant information when it decides, so it can generate the best answer. Let's walk through an example. OneBrain is a piece of technology at Airbnb. It doesn't matter what it does. We're just using it as an example. This is an example of an AI response before RAG. The response is a total hallucination. This is from one of the older GPT versions. In reality, the model has no clue because it's only trained on general knowledge outside of Airbnb. So sometimes those models will give you a plainly made up answer like this, and especially the older models. Often the model will do better and say it doesn't know, and newer models are better at that, which is obviously better than making something up. A way to fix this problem is to add more context via RAG. There are lots of ways to do this, but here's a really simple example. Here we just add more context straight into the system prompt. We first run an internal search. This returns docs and snippets using something called a vector search in this case. Then we quietly append those search results to the system message. And as you can see, we get a great answer. This tells us what it actually is at Airbnb. It's a Python package and a CLI, and this tells us what it's for. So this is a really powerful feature. Another example, something an engineer might ask, especially a new one. How do I generate an iOS project? Without RAG on, we get a generic answer. It's accurate, it's not a hallucination, but it's not as useful at Airbnb because we actually have our own internal frameworks for these things. If we turn on RAG, we get a very useful response. It tells us the exact commands to run to use the internal framework version, and it gives links to documentation for more reading. So anyway, once you build this sort of RAG infrastructure once, this generalizes to anything that's in the document search set across the company. We'll talk later about some recent refinements we have in this idea, but let's move on for now. That completes our coverage for chat. Let's quickly talk about IDE autocomplete via Copilot now. Of course, everyone knows the tool by now. We're not going to dive into that, but I want to talk over some data that we've seen. So this data comes from Microsoft and GitHub. You can find it on their blog. And this obviously looks amazing, maybe a bit too much so, but we do continue to observe value in this. We have lots of engineers that find it highly useful. Our take is that for keeping you in the flow and for boilerplate code, Copilot has been great and continues to improve, and our survey results back that up. So when we first rolled out Copilot internally, we did a bunch of work on adoption given that early success. We made it super easy to use, adding prompts to install in our major IDEs and making the auth all seamless. And from that, we actually got to really high adoption. Around half of all active PR authors started using Copilot. We wanted more though. So that big red arrow actually points to when we did a big outreach campaign. We literally reached out on Slack individually, personally, to every developer that hadn't tried it yet. And most commonly, they just missed our PSA email about it, or they hadn't gotten to it yet. But we often heard back from them after setting it up with really positive feedback. For lots of people, I like to think this was some kind of light bulb moment where they overcame some skepticism about generative AI in general. So now we're seeing active usage numbers in the 70 to 80% range, and this has persisted for quite a while now, which is amazing for a tool at Airbnb. That said, a minority of people still don't like it. Maybe their thinking is thrown off by the suggestions, or in their domain, it doesn't always offer as much benefit. But in aggregate, the impact of this seems like it's been great. Let's dig further into this because we have some really cool data from Copilot. Another way to measure Copilot's benefit is to look at the percentage of Copilot's autocomplete suggestions that are actually accepted. And we do get this data, and it even excludes the cases where somebody accepts a suggestion, but then changes it around completely. So anyway, internally, we see this acceptance rate hover around 30% overall, which seems quite good. Or, as another measure below, we can compare the number of accepted TypeScript lines from Copilot with the overall number of new lines that we see going into our TypeScript monorepo and get a very rough idea of the percentage of overall new code that's being auto-generated, possibly a little bit of an overcount. Anyways, this comes up with something around 10 to 15% of the new code being generated by Copilot. So anyway, that's just an interesting data digression to see what the impact this has had for us. But finally, let's see if we can take on the overall burning question. Does Copilot make devs more productive overall? We can see the lines of code merged in, but that's not necessarily a super satisfying metric. And of course, it's a hard question to answer. So to preface, don't take this slide the wrong way. Airbnb really doesn't use PR frequency or lines of code as a performance metric for folks, because we know this doesn't necessarily correlate with productivity for lots of reasons. But in this case, it's interesting to look at to quantify impact of the tool and see how much people are using it. So anyway, when we had originally rolled out Copilot, we found that the early adopters of Copilot actually saw a meaningful bump in the PR frequency to the tune of about 5% per month. And that doesn't sound dramatic, but it's pretty rare for us to find a clear bump within all the noise in some data like this. And it helps to support the other indicators that we previously talked about. Okay, now let's get into some pretty different stuff. There are a handful of key things that we've done to enable new LLM-based tools and really democratize the creation of these things internally. Now let's talk about them. So first of all, we have a set of LLM proxies internally, which really simplify the considerations around accessing them. We have proxies that you can talk to from any internal service or even directly from your laptop. These connect you to various LLMs, and I'll talk a little bit more about that proxy layer shortly. We have some internal libraries and cookbooks and various docs in various languages that make these things really simple. Next, we have this really cool internal service prototyping framework called Sandcastle. Now, we already have some pretty good frameworks for building and launching new services internally, but that paved path is not super simple for new users, and it's not made for more ephemeral prototypes. Sandcastle wraps that in a super streamlined, user-friendly way and makes it possible to launch a new service prototype in about an hour without any real infrastructure knowledge, so that's great for prototyping. And then finally, we have some internal prompt storage and evaluation frameworks, because given the non-determinism about LLM-based tooling, it's actually quite difficult to make improvements using just ad hoc testing once you've originally rolled it out. So an evaluation framework for making those decisions in a more rigorous way is super helpful. Now, let me be clear before continuing, all of this was not written by our developer productivity team just for dev tooling applications. It comes from all over the company for various purposes, and it's useful for any LLM-based application. And all of this adds up to make it fast and simple to prototype any LLM-based tool with the right safeguards in place. Before I go into a few examples of things we built on this foundation, let me dig quickly into that LLM proxy idea. So in theory, you could maybe distribute some API keys and talk directly to OpenAI or Anthropic. But having some internal proxies and talking to models hosted on things like Azure or AWS really simplifies things and makes them easier to secure. For us, this handles much of the heavy lifting, things like authentication, load balancing across regions, and an audit trail, and really makes them easier to get started innovating. Now, starting this year, the field of frontier LLMs has been hugely expanded, and OpenAI is no longer the only major player in the frontier model game. In fact, we see many top LLM providers now doing training and tweaking specifically for enhancing developer productivity with their models. So to accommodate that, we have a special proxy service for developer productivity usage cases, which includes an API translation layer. That translation layer allows people to write a simple client once against Azure OpenAI APIs and then talk to many different types of LLMs. So for example, you can write a client using an off-the-shelf OpenAI SDK, but specify Claude Sonnet as the model. And if you point to that special proxy, things work seamlessly, even though it's actually talking to a wildly different AWS Bedrock API from that proxy layer. This allows us to very rapidly respond to new model releases that bring productivity improvements to developers, and allows each of those clients to stay as thin and simple as possible. It doesn't need to know about AWS Bedrock or any of the other considerations there. Let me also call out that this backend setup allows us to quickly change the model default across many clients, because our developers shouldn't need to be LLM enthusiasts to know how to get the right impact. So now that we dug into the infra layer, let's go way up the stack and check out some of the fun, super thin clients that we built on top of all that. So first of all, this is ReviewGPT. This was a hackathon project that I wrote way back before I was focusing on AI tooling full-time. I had some good results putting code into an LLM and asking it to find issues. So I thought, what if we actually made this into a tool? And so just a few hours later, on top of that LLM infrastructure, I launched this. So on top of any pull request internally at Airbnb, anybody can tag the bot and it'll check out some changes and respond. The results are definitely mixed here so far. Sometimes the results are very good. Sometimes it gets things wrong, or it's just kind of a non-deterministic linter. Now, I should say we have zero intention of actually removing the human review element. We think that is really critical, even when LLMs get to the point of being able to more reliably spot problems. But this tool is intended to provide an extra set of eyes on that code review. So concretely, this tool can add comments to PRs, but it can never approve PRs for merging. So let's delve into the details a little bit to demonstrate how simple this really was. This is just a little Python script that gets invoked by CI, fetches the changes and the PR description, and then passes it straight to the LLM in the prompt. So one subtle thing to note, since the PR description is passed in here and ReviewGPT knows what its name is, users can actually guide the review in whatever way that they want just by talking to it in the PR description, just like a human reviewer. So to get this working decently, I did a bunch of tuning on the system prompt. You see the usual, telling the bot what it is, what to do, telling it how to parse the git diff and pick out the change lines. And then we have some tuning instructions to avoid crufts, like don't introduce yourself, and always make sure the review is well formatted for GitHub Markdown, which LLMs tend to be pretty good at. After some experimentation, we also added things to try and avoid nitpicking. And it turns out the hardest part was actually getting it to respond, looks good to me, when it didn't find any problems. It turns out that the bot is a really harsh reviewer, and it has a strong tendency to find something to comment on. It loves to nitpick, and that's still a little bit of a problem. So that's ReviewGPT. This is an example of something that's more of a fun experiment for now, but I really expect with new LLM model advances and some work to provide it some more context in the surrounding code base, it could become a significant thing for us. And in fact, this is another case where we're seeing some promising early signs and testing out the new OpenAI models that were released recently. Okay, let's dive into another example, and I suspect those of you on developer productivity teams may pick up a little bit this one. We have an internal Slack bot for internal engineering support. Like most companies, we have a number of different Slack support channels, and this can sometimes be a big burden for infrastructure teams to support. So oftentimes questions that come into these channels could have been answered with a bit of searching over docs and past support threads, or with a little bit of reasoning on top of that content. But maybe people don't know exactly where to look. So we thought AI with RAG could be a great solution for this. This not only provides a better response time for users, especially for users that need support outside of normal work hours, but it also reduces some of the burden on our infrastructure engineers. So we put out this bot that just sits and listens for pings to itself and plumbs through the message to an LLM with RAG integrated. And then it adds some context to the system prompt on what the bot is, how to format the response, and so on. When the LLM responds, we respond back in the same Slack threads with that verbatim response. And that's it for the infrastructure. But again, this is a case where we see more mixed results. The case you see here is more of a best case scenario. It's asking something that's directly answered to the info that it pulled up with nice commands and everything. But lots of times, the articles just don't contain enough information to solve it or point them in the right direction. And it's, maybe a little bit of noise. Overall today, in the channels where we've really tweaked it, we see in the range of maybe 10 to 30% of the issues solved by this bot. And in other issues, it often helps just by running through some common troubleshooting steps with the user that saves on-call time. With some improvements in the RAG that we're making, though, we think this could theoretically address up to half of the issues. So again, this is just trivial little integration on top of those internal frameworks and RAG I talked about earlier. Okay, now diving back in to more of the conceptual view for a moment. This is another idea we've started working on quite recently and has shown some good early results. And this is the last thing we're going to talk about today. Our observation has been that RAG can have much better results when we both narrow the search space and always provide a specific set of high-quality critical documents as background information for the LM. So the general thought here is to create some specific assistance or focus areas for specific domains. For example, we might have an assistant for iOS development at Airbnb or for our internal service infrastructure. And each of those has access to specific information and golden example code just related to those topics. So with that in mind, this slide highlights a 3-tier architecture that we're moving to. These assistants are a set of configs pointing to different information sources, prompts, and so on. And then the next tier, all of our client interfaces like IDE plugins or the Slack bot I showed you can pick an assistant that it wants to respond. And then, of course, we have our shared infrastructure layers that we talked about earlier. So this sort of idea is one of the reasons that we now have things like our custom IDE plugins. That enables this sort of unique customization ideas that we think will be super powerful. Sketching that out a bit further, we're making it possible for anyone internally to create one of these focus area assistants. We're building a framework that allows all sorts of teams to define these sort of tightly scoped assistants for their own areas. This is a busy slide, so I'm not going to talk over all of it, but this is roughly the development process that we're thinking of. We have prompts, golden examples, and RAG filters defined in a single place. We have some functionality to test it out on various integrations, and we have some functionality that integrates with an eval framework to allow us to test updates to it. Again, this is still a fairly new idea that we're still working on, but our early results show that this should provide much more reliable results on those RAG results. And that's what I have to share for today. Thanks for listening.